Hi, everybody. Welcome to week 4 of algebra of quarter 4. In this video, I'm going to go over the first 3 problems in the homework. This week, we're focusing on the Pythagorean Theorem. And I'm starting to advance. I can't use the whiteboard app right now, so I'm going to have to draw pictures that go with our questions. So here in question number 1, we have a right triangle, and that's the best right triangle I've got. And this is C, this is A, and this is B. And we're given the area of B squared. Here, the area, let's not use A. Here for B squared, the area is 64 square feet. And we have the area here for A squared, and that is 225 square feet. And what we want to figure out here, in addition to what A and B's length are the length of C and the area of C squared. So we want to know what is the area here. We want to know what C equals, what A equals, and what B equals. All right, so we're going to use the Pythagorean Theorem. And that theorem says when we're given a right triangle, so we have a 90-degree angle here, a right triangle, the side length of the legs squared, so A squared plus B squared, is equal to the length of the hypotenuse, which remember that's the long side across from the right angle, also squared. All right, so we already have the area for B squared, that's 64, and we have the area for A squared. That's 225. So I'm going to start by plugging these into the formula. So A squared is 225, and B squared is 64, and we're going to solve for C squared. So actually, we're going to be solving the 4 parts of this problem a little bit out of order, but that's okay. I'll make sure to label them. And this just makes sense because we're already given A squared and B squared. So we're going to solve in the formula first. All right, so when I do 225 plus 64, I get 289 as my value for C squared. So now this is going to be what this area here is. And that's the bottom part, number 4. Or I should say part 4. The area of C squared equals 289 square feet. All right, now I can actually go back and solve for the length of C. And then we'll go back and solve for the length of A and for the length of B. Okay, so I know that if I have something squared equals 289, I can find just C and get rid of the squared by doing the opposite, which is the square root. So I do the square root on both sides, and this you would plug into the calculator, and that's going to give you positive 17. Now, I know in the last couple weeks we've talked about when you do the square root of a whole number, it could be the positive answer or the negative answer. But because we're talking about length here, we can never have a negative length. So this length is just going to be 17. So that's the length of our hypotenuse, 17 feet. And now we're going to solve for the lengths of the 2 legs. So I know that A squared equals that 225 feet. So I'm going to do the same thing to find A. I'm going to do the square root on both sides. And I know it has to be my positive answer. So here A equals 15 feet. And then I go ahead and do the same thing for B. I know B squared is 64. I do the square root on both sides. I know to take the positive answer. B is 8, so that's going to be 8 feet. All right, so this is how you solve problem number 1. And in just a moment, we're going to go over problem 2. Take a second to look at this. If you have any questions, please write them down and email them to me. All right, let's go over question number 2. Question number 2 gives us the right triangle. Whoops, a little bit too long there. Gives us the right triangle with sides M, P, and Z. Now remember here, M, this is our hypotenuse. That's the C part of the equation. And these are our 2 legs. And either one can be A and either one can be B. I'm just going to call this one A and I'm going to call this one B. The important thing is we know that the hypotenuse is C, and that's across from this right angle right here. Okay, so M, P, and Z represent the lengths of the 3 sides of this right triangle. And it asks us to select all the equations that represent the relationship between M, P, and Z. So they give us 6 options. I'm going to write them out really quickly. Hopefully they can all fit right here. All right. Option 1, P squared plus Z squared is M squared. Option 2, P squared plus M squared is Z squared. Option 3, M squared plus P squared is Z squared. Option 4, M squared equals P squared plus Z squared. Option number 5, Z squared plus P squared equals M squared. And option number 6, M squared equals Z squared plus P squared. All right, so I have the 3 legs in the Pythagorean theorem, and we want to figure out which one of these equations is correct. So remember our Pythagorean theorem. That's that AX squared. Oh, whoops, sorry, I'm thinking about quadratics. That's the A squared plus B squared equals C squared. Okay, and like I just said about a minute ago, the important part here is to recognize that M is the hypotenuse, the C squared. So this is going to be M squared. It's going to equal M squared. And here I said that we could switch the legs if we wanted to, but for now I'm going to start with A being leg P. So this is going to become P squared. And Z being leg B. So this is going to become Z squared. So when I first put M, P, and Z into the Pythagorean theorem for the A, B, and C, this is the equation I get. And this equation matches number 1 here, so we know this is true. Now, if we look at the other ones, there's a couple things we can do here for process of elimination. Because it always has to equal the C squared, this part that's equal to M squared isn't going to change. M squared is going to be by itself if these are all plus signs in the equation. So here it can't equal Z squared, and this one can't equal Z squared. So we know 2 and 3 cannot be correct. Now, if we look at our other options, the other 3 are equal to M squared. So we just need to figure out which one of those 3 are correct. So if we look down at number 6 real quick, this is the same thing as number 1. We just switch the 2 sides of the equal sign. Here it equals M squared, which we have. And on this side of the equal sign, I have P squared plus Z squared. Here I have Z squared plus P squared. That's the same thing. Remember, you can switch the order of an addition problem. So number 6 is correct. Now, if you look at number 5, this is very similar. I have Z squared plus P squared on one side, just like down here, and it equals M squared. So this one is also right. Here, this very last one, the M squared equals P squared plus Z squared. This is just the reverse order of number 1. I have the M squared, it equals the P squared plus the Z squared. So that one does work. So the 4 that work here are choices 1, 4, 5, and 6. Again, if you have any questions about number 2, please email me, take a screenshot if you need this, and write down your questions. We're going to go over one more question in the homework, which is number 3. It is a real-world scenario, and then I'm going to have you finish questions 4, 5, and 6 on your own. So I'm going to go ahead and pull up question number 3 here. It gives us a little TV. And here's a little TV stand. And we're saying that the TV across, which is how you actually measure TVs, by the way, is 40 inches in what we call the diagonal, because it goes from one corner to the other. And we're saying the length of the TV here is 24 inches. And this is going to be one of our legs. This here, I know it doesn't look like it in my drawing. This is a right angle. So we have the triangle here with side A equal to 24 inches. Our hypotenuse C is 40 inches. And we want to figure out what this width is, what B equals. So again, I'm going to set up the equation for the Pythagorean theorem, a squared plus b squared equals c squared. And I'm going to plug in my numbers. I just said a is 24, so I'm going to do 24 squared. B squared is what I'm solving for. And that's going to equal my hypotenuse, which is 40 squared. Once I plug in the numbers, then I'm going to start doing the math. And I would definitely use a calculator for this. I'm going to be just typing it into Google as we go. So 24 squared, remember that means 24 times 24. We're multiplying 24 by itself. And that gives us 576. We don't know this b squared yet. We're going to bring it down. And when I do 40 squared, remember that's 40 times 40. That gives me 1,600. All right, I'm running out of room here, so I'm going to go ahead and write this up here. And I'm going to keep going, solving for that b. So I have 576 plus b squared equals 1,600. Now I want to start by getting the b squared by itself here. So what I'm going to do is I'm going to get rid of the 576 and move it to the other side by subtracting 576 from both sides. When I do that, I'm left with b squared on the left side, which is what I want. And 1,600 minus 576 is 1,024. Now, to go from b squared to just b, which is that width I'm trying to solve for, I'm going to get rid of the squared by doing the square root on both sides. This is definitely going to be calculator work. Remember, you can use that calculator in Desmos that is linked into the announcements in Canvas. Or if you just type it into Google, you can type in SQRT parentheses 1,004 and then close the parentheses. And I'm going to go and do that right now. When we do that, the answer gives us 32. Remember, we only take the positive answer because the negative answer isn't possible. We couldn't have a TV that's negative 32 inches wide. So we always want to include our units. This is inches, and this is our final answer. Again, if you have any questions about the Pythagorean theorem, any questions about questions 1, 2, or 3 on the homework, or even anything else that we've done in quarter 4, please email me or try to attend the Zoom session and we can work on this together.